So then there's really, I think, three main ways that this transfer happens. One is a direct thermal transfer, if you like, heating. And we sometimes talk about the ocean and the atmosphere as being heat sinks. The ocean definitely thermally conducts heat, and that can cause convection in the ocean or drive ocean currents where, same thing again, some parts of the ocean are heated more than other parts of the ocean, and so you have warm bodies of water that are buoyant and cooler bodies of water that tend to sink. And so up near the poles where the ice caps are, the water there is cooler and tends to sink to the bottom of the ocean, and around the equatorial region we might have that water warming and rising nearer to the surface. And so then we also have factored in the spinning, the anti-clockwise, if you like, this way, spinning of the Earth that contributes to movement of those cycles. Essentially the process is driven by this transfer of energy from the sun. Now, similar sorts of things can happen with air masses in the atmosphere, although the atmosphere is not quite as good at conducting that heat energy, and often sometimes the energy comes back off the surface of the Earth to drive the processes for the movement of air masses. But essentially what happens is similar, where the cooler air masses move differently to the warmer air masses, and in the process of trying to establish a sort of an equilibrium, air masses move around in systematic ways, also further complicated by the rotation of the planet. And we see these spiral air masses moving around the Earth that we see as trade winds and those sorts of things. And then locally there are variations depending on topography and those sorts of things. The key point here is that the energy that's driving these transfers of heat energy and ultimately movement of different masses that are warmer or cooler comes from the sun.